Hello, hello, and welcome to Pre-Calculus 12. We are into section 0.6. This is our second part of review for Pre-Calculus 11. So let's get into this. So what are the purposes? Again, just to bring your brain back into math mode and to give you a little bit of a practice on note-taking. And we're doing factoring today, so that's what we're going to be reviewing. And also a little bit of simplifying rational expressions. So, greatest common factor. Let's look at some examples for this. Again, for these reviews, I'm not going to go in depth into all the material, but just give some highlights as we go through this. So, here's some examples here. So, a reminder, greatest common factor is what is the biggest number I can factor out of these terms. So, for here, I've got 2x minus 10. So the greatest common factor that I can take out of this is 2. Because both terms don't have an x, I can just divide out a 2 out of both of those. So factor out the 2, and what I'm left with in brackets is x minus 5. So you can always double check your work with this. Multiply it backwards, multiply the 2 into the brackets, and see what you get. See if you get the original. So I often find it's easier to multiply than it is to factor. So you can just multiply and double check your work. Let's try it with this one. So we've got 9x cubed plus 6x squared minus 15x. So in this case, we need to look at what's the biggest factor that we can take out of each of these. So looking at the numbers, I've got 9, 6, 5. The biggest thing I can divide out of all three of those would be a 3. So I can factor out a 3. And looking at the variables, each term has a variable x. So just an x to the power of 1 is the highest that I can factor out. So my greatest common factor is 3x. So I factor that out. And the brackets there, again, you divide each of the terms. So 9x cubed divided by 3x, you get the 3x squared. And you do that for each term. Let's try something like this. So again, you just look at each thing. So looking at the numbers, I can factor out a 2. Looking at the a's, the greatest factor that's in all three terms is going to be a to the power of 1. B's, it's going to be b to the power of 1. And if you look at your second term, minus 2a squared b, there's no c term. So I can't factor out c. I can just factor out the 2ab, which gives me this. Divide each term, you get what's in the brackets there. So that's your greatest common factoring. Now let's look at factoring trinomials. So here's an example. We've got x squared minus 5x minus 6. The strategy I always teach for this, at least at the beginning here, is you need to find what two numbers add up to give you the minus 5 that's in the middle, and those same two numbers need to multiply to give you the last number, minus 6. So if you think about this, what two numbers will do this? Well, we've got minus 6 plus 1. So minus 6 plus 1, that'll give you negative 5. Minus 6 times positive 1 will give you minus 6. So those end up being my factors, x minus 6, x plus 1. And that's factoring. That's the easier one. Now, if we look at this one, I've got a term that's in front of x squared. That's a problem. It's going to make it a little bit trickier, but essentially the process is still the same. First thing I'm looking at in this equation is the fact that I can take out a 2 in each of these terms. So I can actually do a greatest common factor first, factor out that 2, and then I need to look at something similar to what we did the last one. So what two numbers are going to add to the middle term, which is minus 1, and instead of looking at what two numbers multiply to minus 2, I need to also take into consideration that 6 that's in front of the x squared. So I'll get this. What two numbers multiply to give me 6 times negative 2. So that's what I'm going to be looking at. What two numbers add to negative 1 and multiply to negative 12. So here we go. That's going to be minus 4 plus 3 will give me that. Notice here I didn't just start putting things in the brackets like I did before. I actually separated that minus x in the middle into minus 4x and plus 3x. Once I've done this step, I'm now going to partially factor. So I'm going to take 6x squared minus 4x. I'm going to factor that, figure out what's the greatest common factor and take it out. And I'll do the same with 3x minus 2. So that looks like this. So my 6x squared minus 4x, I factored out that 2x, and I was left with 3x minus 2. And then with my 3x minus 2, I can only factor out a 1. So therefore, it's just going to stay as 3x minus 2. And then these are going to give me my two brackets. So I've got 2 stays outside. Then I'm going to have 2x plus 1 in one of the brackets, and the 3x minus 2 in the other bracket, which gives me this. So that is completely factored. Now let's look at simplifying rational expressions. So here's a rational expression, and we need to simplify this. So when you see something like this, a fraction that you can simplify this down, what you can imagine is each of these, you can break this up. So I can break it up into the numbers, the w's, the base x, the base y, the base z. So I can imagine this. Essentially, I can just break it up into each chunk and deal with those separately, because these are just the exponential rules that I showed you last class. So 15 divided by 10, simplify that to 3 over 2 by dividing it by, dividing both by 5. Then w to the power of 5 divided by w to the power of 7. I subtract those powers, so 5 minus 7 gives me negative 2. X squared divided by x gives me x to the 1. Y to the 4 divided by y to the 5 gives me y to the negative 1. Again, subtracting those powers. And then z to the 6 divided by z to the 2, that gives me z to the 4. So this is what each of those terms simplifies into. So I can just write that out as such. And then I don't want to have the negative powers, so I'm going to flip those. So this would be our final answer. Again, just taking the w and the y, because those have negative powers, and putting them in the denominator. Let's look at a little bit more complicated one. So here, again, I want to simplify this. Now, please, please, please do not just cross out x squareds. I can't do that, okay? Because you've got adding and subtracting. You cannot just simply divide out x squared. If all of these terms were times each other, yes, you can factor them. But since there's adding and subtracting, you cannot just simply divide those. So what you'll need to do is you'll need to factor these. Now I left these as the simple ones so we can take a look. So I need two numbers that add to negative 7 and that multiply to positive 12. So that would be negative 4 and negative 3. And x squared minus x minus 6. What two numbers add to negative 1 and multiply to negative 6? So that would be negative 3, positive 2. So if I'm doing that, I can now split this up into separate brackets. If I look at these brackets, I've got an x minus 3 term on top and an x minus 3 term on the bottom, so I can cancel those out. And what I'm left with is x minus 4 divided by x plus 2. So this is how you do something like this. If you're given a trinomial, you can probably factor it. All right, so that is what we're going to be doing in this video today. So in class, as you can see in this pattern so far, come with your questions. Any questions you have, come to me and ask them, or ask your classmates, figure that out. And then we're going to be working on the review booklet. So again, you should be staying caught up with this. If you should have had a chance to do last class, now you get a chance in class to work on this. So come to class with your questions, and I will see you there.